So the first thing you'll notice, this is similar to one you had from homework. They are in a different order. So remember when we first started talking about elimination, which is the way you were supposed to solve these particular ones, is that the variables have to line up. So if they don't, you can just rearrange them. Just make sure you keep the sign the same. So for example, this is a positive 2b, a positive 3a. So when you switch them, keep them that way. If you were to have to switch these, you would make sure you'd keep that negative with the 3b when you switched it. So just pay attention when you have to switch them around. All right, so you do want to put them in the same order. So I'm going to rewrite the first one to be 3a plus 2b equals 18. I'm going to leave this one alone. 5a minus 3b equals 11. All right, to solve by elimination, I have to get the same number, but then opposite signs. So for this one, I would actually try to eliminate b, all right, because I already have a positive and a negative. So I'm not going to have to multiply something by a negative here. You could eliminate a if you want to. Both of them will work. If you eliminate a, you're going to have to multiply the top one by 5, the bottom one by like -3. If you eliminate b, you're going to have to multiply the top one by 3, the bottom by 2. All right, so here I would eliminate b. Smaller numbers to have to multiply, and I don't have to worry about multiplying by a negative. All right, so I would take this top one. My common multiple between these two is going to be 6, so my goal is to get those to 6s. To get the 2 to a 6, I have to multiply by 3, so I have to multiply everything by 3. To get the 3 to a 6, I have to multiply by 2, and it's already positive and negative, so they will cancel once they're the same number. So you're basically distributing that number through. 3 times 3a, that's going to give me 9a. 3 times the 2b, 6b. And then 3 times the 18, 54. All right. And then I'm going to do the same thing with the 2. 2 times the 5a, 2 times the -3b, and then 2 times the 11. All right. And I have to actually write the 22 when I multiply it by the 11. That helps. All right. So you have to multiply every single thing by that number that you were using to eliminate. And now you can see that if I add down, a variable will eliminate, which is my goal here. So I'm going to add this down. 9 and 10 give me 19a. These cancel, so then I just have the equal. 54 and 22, what do I get there? All right, 76. All right, what's my final step here? I'm going to divide both sides by that 19. All right, it is divisible by 19. What is 76 divided by 19? It's 4. A equals 4. Am I finished? No, I'm not finished. I have to solve for b. You can plug it into either equation. It doesn't matter. So 2b plus 3 times my a equals 18. 2b plus 12 equals 18. Subtract your 12. Divide by 2. So my answer here is going to be A, B. 4, 3. All right. So for this one, it's a little bit more difficult because I do not have a positive and negative. Now, it's already in the right order. I still would actually eliminate the y here because it's going to be multiplying by smaller numbers. If I cancel the x, the smallest multiple between 5 and 7 is actually going to be that 35, right? And so I'd have to multiply 1 by 7 and 1 by 5. A little bit bigger numbers, not horrible. The 4 and the 3, a little bit smaller numbers. So it just depends on which one you want. But you are going to have to negate one of those, right? Because both of my x's are positive, both of my y's are negative. So when I do this one, I am going to have to multiply one of them by a negative number and one by a positive. And it doesn't really matter which one. You just have to do that. I would probably multiply the bottom one by the negative just because I know that my numbers there are going to cancel. But either way, I'm going to have to do a positive and a negative here when I do this one. So just keep that in mind as you do it. All right, so we're going to take the 5x minus the 4y equals 7. And we're going to multiply by what to get that to be between 3 and 4 to 12, right? So I need one positive 12 and one negative 12. So what do I need to multiply the top one by to get that to be 12? I'm trying to get this y instead of a 4 to be a 12. So what do I multiply by? Yeah, 3. Okay. And then I'm going to take my bottom one, 7x minus 3y equals 2. And I need this to be 12. But this guy is going to be negative 12. So I need this to be positive 12. So what do I have to multiply that guy by? 4, specifically negative 4. Okay. So when I'm trying to make one of them positive and one of them negative, I'm going to have to do this. Over here, I didn't because I already had one positive and one negative, right? I already had one positive and one negative when I switched those, all right? So here I'm going to have to actually multiply by negative. So 3 times 5x, 3 times negative 4, and then 3 times 7. And on the bottom, negative 4 times positive 7 gives me what? Right? Negative 4 times negative 3 gives me what? Right, so make sure you're doing that negative all the way through. Negative 4 times positive 2, negative 8. So that negative goes through all of them. All right? 15 and negative 28, what is that? What's 15 and positive 15 and negative 28? There we go, negative 13. These cancel. What about positive 21 and negative 8?
No, 13.
Just regular 13, yep. And then my final step to solve for x, divide by negative 13. So x is negative 1. And then I'm going to take it and plug it back into one of these, right? Doesn't matter which one. 5 times negative 1 minus 4y equals 7. Negative 5 minus 4y equals 7. Add my 5 over. Negative 4y equals 12. Divide by negative 4, y equals negative 3. So my answer here, that's a negative, is negative 1, negative 3. All right, mark. For this one, they actually had the same coefficients, but one was positive. I mean, they were both positive, so we need to either negate both or subtract. I personally negate everything because I feel like there's less room for error. So if you negate, so if this is positive, I need this one to be negative, which means every single thing on this row needs to change signs because I'm multiplying by negative 1. So this would become negative, this would become negative, this would become positive. All right. And once I have that, then I can add down positive 2 and negative 2 cancel. 9 and negative 1 give me an 8. And then 30 and positive 2 give me 32. And then I can divide by my 8 and get my 4 there. All right. Once I have that, plug it back in. 2 times f plus 4 equals negative 2. So we're going to subtract my 4, divide by 2. And so my final answer here looks like this. So we have 2y plus x equals 9. We have 3x minus 2y equals 7. What's the problem here? They are in the wrong order, okay? Oh, that will make a difference. So this is one that you did have to switch. And then it was already nicely set up for you, right? They already have a positive and a negative of the same number. And so for this one, you have a little bit nicer setup when they do this particular one. So we have talked about 3 ways to solve systems of equations. Substitution. The disadvantage is that this can be one of the most challenging is substitution. All right. I see kids struggle the most with substitution. They maybe mess up their distribution. They forget that there's a negative there. And so there's a little room for error with substitution. But it can be faster if you already have a variable that is solved or if you already have one that is easy to solve. It can be the fastest method. Elimination. Sometimes you have to rearrange it. This works best when you have coefficients on all of your variables. Because when you have coefficients on all of your variables, substitution is going to be a pain. You're typically going to have to work with fractions the whole time until the very end. Graphing. This is easy because graphing is rather simple for most people, but it's not as precise sometimes. So if you see that it's going to be a really simple, plug it in and they're going to cross nicely, or you can show very quickly that it's going to be parallel, then graphing is an option that's pretty simple. But if you see that it's going to land on like a fraction, not as easy, because then you're estimating what your answer is as opposed to giving an exact answer. And so we're going to look at different why you would do certain things, So this particular system, we have x plus y equals -3, x minus 3 equals -2. How do you think I would solve this? Substitution, elimination, or graphing? Yeah, I'm going to solve by substitution. Basically, they have a variable already solved for you. Look at that, x minus 3 equals -2. There's actually only one variable in that equation. So if I look at this second equation, to solve for x, what do? Add 3. So I already know that x equals 1. Like, I've already solved for one variable. I didn't have to eliminate anything. And once I know a variable, technically I am using substitution. I'm going to take that and I'm going to replace it in this equation for the variable that it is equal to. 1 plus y equals -3, subtract 1, y equals -4. And so my answer here is 1, -4. Substitution, definitely the easiest here. I wouldn't bother graphing and I wouldn't bother doing some type of elimination. It's not necessary. All right, so when you can very quickly and easily solve for one variable, solve and substitute. Very simple. All right, let's look at example 2. Example 2. For this one, substitution would be a pain to do. Why would it be a pain to do substitution here? I have 3 and 4 and 3. I'm going to get a fraction if I solve for a variable there. 2, 7, and 31. I am going to get a fraction if I solve for a variable there. So this is one I would do elimination for. All right, even though elimination would be kind of big, I could multiply by 2 and 3, or 2 and -3 rather, and solve with elimination. If I saw this, I wouldn't even bother graphing and I wouldn't bother doing substitution. No reason to do that. So for this one, I would definitely solve by elimination. All right? Are y'all starting to see visually why there are multiple ways to solve, right? Look at example 3. Y equals 3x plus 5, y equals x minus 3. There are actually two that would be kind of simple here. Substitution or graphing. These are already in slope-intercept form. Okay, they're already in slope-intercept form. If you look at the graph, when they graph this, it crosses perfectly, right? And it was already in slope-intercept form for you. You didn't have to manipulate it to get it in slope-intercept form. It wasn't in standard form. And so graphing when it's in slope-intercept form, sometimes easier. All right, it crossed directly on one. You can see they started at 5. And remember, if you go off the graph, 2 negatives. So down 3 over 1, down 3 over 1. You can just walk that all the way down here. Started at -3, +1 slope. And you can see we have a perfect cross there. All right. And then look at this last one, solving the system. Again, two possible ways. You could use substitution because any of those variables would be very easy to solve for. I personally would solve elimination here. I would just negate one of those, right? What happens though when I negate all of those and add down? This is a special case. -x and +x. +y and -y. 7 and -5. I get 0 equals 2. Well, that's a problem, right? 0 equals 2 is definitely a situation. When does 0 equal 2? Never, all right? Never. 0 never equals 2. Let's look what happens when they graphed it. We talked about different systems. You can get a parallel line when you're solving another way. It's just going to look like this, all right? It's going to look like this right here. It's going to be a false statement because there is never a time that those numbers equal each other. There is never a time that these lines cross each other, okay? So when that happens, you would say there's no solution here, or you could use your empty set. You could use that guy. There is never a time that those two lines equal the same coordinate pair. So in graphing, it looks like parallel lines. In solutions, either by substitution or by elimination, you're going to get a false statement. You're going to get something that says, two numbers equal each other when they actually don't. And all that means is they were parallel. You can get all three types of answers no matter what method you use. You can get one answer where you get an XY that works for both of them. You can get a parallel line where you get some number equals another number and it's not true. You get a false statement here. All right, a false statement. Or you can get the same line. Remember, we graphed some of them in the same exact line. That means the entire line is your answer. When you do it solving, you'll get a true statement. 0 equals 0. That's always true. So when it's always true, they have given you two of the same line. When it's never true, they have given you parallel lines. And when you get an answer with an XY, they've given you lines that intersect. So this is a visual picture of what it looks like when you solve. This is what looks like your answer will look like when you solve them algebraically, not graphing. Okay? But those are the three types of answers you can get. One ordered pair, parallel lines, or the same exact line. All right? Those are the three types of answers you can get.